The learning objective is to learn about how counters, interrupts, and clocks are used to optimize code for real-time processing. Infrared LEDs are low-cost devices that emit light in the infrared spectrum. The infrared receiver is a phototransistor that varies the amount of voltage that flows through it depending on the amount of infrared light it detects. Operational amplifiers are used in many signal processing circuits. A quad op-amp chip contains 4 independent operational amplifiers running off of the same power supply. The idea behind this heart rate monitor is simple. As the amount of blood being pumped through your veins varies because of your pulse, the amount of infrared light that is reflected back at the infrared receiver varies, and thus causes a varying voltage signal through the circuit. The change in voltage is too small to be easily analyzed, so the signal must be passed through an amplification circuit and a noise filter in order to extract important information from the signal. When you tell a lie, your heart rate varies significantly. This variation in pulse can be detected by the Arduino, which can then alert the user to a potential lie. The first op-amp amplifies the signal and passes it along to the second op-amp. The second op-amp cleans out the signal by filtering out noise. The transistor does a second stage of amplification, and then the signal is sent to the Arduino. In order to visualize your pulse, you must first download the processing software. A link to download this software will be included in the assignment. Pulse max is used to record the maximum pulse voltage. Pulse min records the minimum pulse voltage. Tick value sets the value above which a heartbeat will be counted. Pulse up is a software flag that tells code to increase the number of total pulses counted. Pulses keeps track of the number of pulses since code has started running. BPM stores the current beats per minute of your pulse. Old BPM stores the beats per minute at last reading of your pulse. Delta BPM records the change in beats per minute since last reading and is used to detect lying. When this value is sufficiently large, this signifies that you are stressed out and are probably lying. Millis returns number of milliseconds since the code has started running. Counters. The pulse variable is an example of a counter. Some common mistakes to check for in the amplifier circuit are verifying correct connections to the op-amp, verifying that no short circuits exist, verifying correct orientation of capacitors and LEDs. Some common mistakes to check for in software include verifying closed parentheses and other syntax, as well as verifying proper ports declared and desired baud rate.